myself. I'm Ataullah Burrito. Okay, so I will like to start my presentation with brief outline. We will start with the motivation. I'll discuss a bit about smartphones, why they are so popular, and which type of data they actually generate and store, and how to protect that data. Then we talk about existing authentication mechanisms, okay, and their limitations, a bit about their limitations. We talk about the solution to actually protect such data which is generated and stored on the smartphones. Then I will propose SwipeGAN, because there is a major challenge in development of behavioral biometrics, and that is about the limited number of samples. So how we use SwipeGAN to tackle this challenge, and I'll conclude the presentation with some future dimensions. So here we go. Smartphones, actually, they are very popular. Why? Because of their increased features, like they provide anytime, anywhere computing. They have content power processors, actually, and long-lasting batteries. So as they provide anytime, anywhere computing, we use smartphones for a variety of applications, like taking pictures, making movies, sharing those movies with friends, families, and colleagues, for example. And all these things, they actually come in the form of apps. So we have applications for social networking, we have applications for online transactions. So we do a lot of stuff on smartphones, actually. So the downside of this is actually that these devices, they actually track the user location. They have the full control over users' personal data, emails, transaction details, everything. So all the point is, like, all these applications, they generate and store very personal, specific user information, which in any case needs to be protected. Okay, in case that phone is stolen or is found by some adversary, it could be a nightmare for the victim. So authentication is actually considered as the first line of defense. It actually proves the identity of a user. On smartphones, we have a limited number of authentication approaches. For example, we can broadly categorize them in two types. One is knowledge-based and another is characteristic-based. So biometrics mean. So knowledge-based authentication systems, authentication schemes like pins and passwords, they are very, very popular. Okay, and characteristic-based means biometric modalities. They are already on the phone. Fingerprint, face, iris, lips, ears. They are actually examples of static biometrics. And still, there exist some behavioral biometric modalities, but still they are less. They are actually awaited in the real world scenario, the real world application. So, like keystroke, the way you actually print, the way actually you type something, the way actually you sign something, and based on sensory readings from accelerometer and gyroscope, which is already on the phone. We can use these motion-based gestures to identify users as well. So they all come under behavioral biometric modalities. The limitations of these things, like knowledge-based and physical biometrics, is that they require active user participation, number one. So every time, for example, recent studies suggest that the users use their smartphones very frequent, but in shorter sessions. So 150 times a day, for example. So in 150 times a day, it's a cumbersome practice actually to provide face as an evidence for to measure the authentication, for example, or to identify the person, or every time you need to access the smartphone, you need to enter PIN or password. It's cumbersome. So this way they pose actually usability issue. Similarly, they are hackable. They pose security threats as well, like fingerprints. For example, Chaos Lab Germany managed to hack 2 of the latest smartphones, touch sensors of the smartphones, for example, iPhone 5s and iPhone 6s. So knowledge-based and characteristic-based, but physical biometrics, they have shown to be comparatively less secure and less usable as compared to behavioral biometrics. So actually the point is pins and passwords could be used, or physical biometrics could be used on smartphones, on for example, on some things like that offer longer sessions. For example, after entering password after 2 hours is fine, but these schemes, they actually do not fit in the current interaction model. For example, shorter but frequent sessions for new devices, especially on the smartwatch or on the smartphone, for example. So there is a need of newer usability driven but secure metaphors. Of course, they should be secure. So behavioral biometric-based authentication schemes, they have actually shown to be widely accepted by the users, and as well as they are comparatively secure as well. So behavioral biometrics is very simple. It means you are supposed to use human gestures. You know, the user apply different strategies, different style to perform something, for example. So identify a user based on the movements he makes or the way he holds the phone could be used as a biometric modality. The advantage of this type of biometrics is like for experimentation or for data collection, we are not supposed to collect like we can collect data unobtrusively without even letting the user know that we are collecting the data, and there is no need of additional hardware. For example, you can exploit the keys actually to collect keystrokes. Okay, and arguably they are very secure as well. But among some other challenges, like applying machine learning models on the smartphone, actually applying CNNs or advanced machine learning techniques, for example, on the smartphone, there exists a major problem, which is like normally due to the higher intra-class variations in the samples of the same user. Okay, this classifier, the classifier which is being used in these schemes, they don't learn well actually. So as a result, the accuracy of those models, due to less number of samples, accuracy of those classifiers is not up to the mark. So that's why the real the deployment of physical biometrics in the real world is still awaited. To solve this issue, we propose SwipeGAN. Now, so what is SwipeGAN? It actually is a very simple GAN, okay, using multi-layer perceptron, okay, to generate high-quality synthetic behavioral biometric samples, especially swipes in this paper. So GANs are not new. GANs are very popular in multiple fields, in image and video generation, speech generation, for example. However, their use in behavioral biometric domain is relatively new. So the approach, I summarize this approach in 3 parts. So in the first step, if you see, I train and test the classifier on the original data. The data I'll talk about later. The data could be downloaded from a publicly available paper, or open access paper, you can download it. So I trained and tested this one class classifier here, okay, on the original data set and obtained the baseline results. Then what I did, I applied GAN to generate synthetic samples, okay, for each user individually, and obtained like 20 matrices of 120 by 33 samples. Why 20 matrices? Because I saved this data after 500 epochs. So in total, I ran 10,000 epochs and managed to save 20 matrices. But for the analysis, I used only the samples that were generated after 10,000 epochs, because it is expected that the GAN had become stable at that time. And in the third step, what I did, I used the augmented data to train the classifier and test on the same data as in the step 1. So analysis shows that, okay, in the analysis, I have some lines I would like to say. You can download this data set collected from 86 users, and it's publicly available. The link is here. And actually, they have the authors of this original study. They have uploaded the data in the form of features. So I didn't added any feature whatsoever. So we used only the features that were already listed there, and we adopted a random forest one class classifier for testing this. Why one class classifier? Because we believe that smartphone user authentication is a one class classification problem, because you are supposed to train the model on the phone with only the samples of the positive users, the legit users. So this is how the like we can visualize how the synthetic samples were generated. From this figure, you see I compare the two users, the features of two users. In red dots, you see these are features, fake features generated by GAN, and below are the original ones. So in horizontally, vertically, you see these are the samples after 500 epochs. And you see there is a lot of difference between red and blues here, but these are the samples generated after 10,000 epochs, and you see they are basically overlapping the original blue samples. So these are for the two users. These two graphs are for user 31, and this is for user number 37. So how to evaluate these GAN samples? So here, actually, since the swiping samples, they are in the form of a vector, we tried implementing dynamic time warping algorithm to compute the distance between the original samples and the generated samples. And if this distance is 0, means the patterns are identical, the samples are identical. So lower the distance means higher the similarity. So we observed that the distance between the original and the generated samples, it was very small, not very big. So, and for the classification results, just to prove the point we wanted to prove is that with more increased number of samples, with more number of samples, for example, the classifier learns well and it results in higher accuracy. To prove this point, you see here, these are the results obtained on the real data. True acceptance rate of 84.66 and false accept rate of 14.78. So as we increase the number of training samples, so for example, take this one, real plus 100%, it means 120 original samples, we added another 120 samples that were generated after 10,000 epochs together and form a training matrix of 240 samples, let's say. So with this, for example, we reached this true acceptance rate of 91.65, and also the false accept rate decreased to 11.04. So this actually proves the point that higher the number of samples, training samples, the classifier is more likely to be more accurate. Okay, with just to summarize what we did, what I presented is like we proposed here SwipeGAN, multi-layer perceptron model to generate synthetic samples for smartphone user authentication. We empirically show that increasing the number of training samples, the TAR increases and FAR decreases. So as a short-term future work, for example, we plan to implement this proof of the concept application based on our findings and see like how it behaves on the real scenario, on the real phone, for example. So we plan to evaluate our application in terms of computational cost, accuracy, and power consumption. Thank you so much. Now I would like to have